If you are following along from home, you can just write the vocabulary on a blank sheet of paper. All right, let's get started. On your assignment sheet, I listed out the vocabulary that we're going to be covering each day. Some days it's a whole bunch, and some days it's nothing. There aren't new vocabulary terms to learn. So let's take a look at, we're going to go through today's lists. The first thing I'm going to introduce is supplementary angles. Okay, so that is when two angles have a sum of 180 degrees. So two angles with a sum of 180 degrees. That's our first angle relationship that we're going to talk about. And I'm going to draw a picture too to show you. I'm going to label some points on here. Okay, so these two angles would be an example of supplementary angles because you can see that they add to 180 degrees, okay? That's one example. And I can write a statement for this, and I'm going to do so just so that you can see how to write the angle names. We can say that the measure, M, of the angle ABC plus the measure of angle CBD is equal to 180 degrees, okay? Supplementary angles that look like this also have a special name. We call it a linear pair. So this would be an example of a linear pair. Because one side is a line. That's why it's called a linear pair. It's a pair of angles that have one side that makes a line. Now, sometimes the angles are not touching each other, but they still add to 180. So, for example, you have E, F, G, and then maybe you have another angle. That is H, J, K. So we can say that the measure of this angle, the measure of angle EFG plus the measure of angle HJK is equal to 180 degrees. So that's another example of a supplementary angles. Now I want to point out that when we're writing the name of the angle, we always have the points on the sides the rays basically on the outside and the vertex in the middle. So notice that I have EFG. We wouldn't want to call that angle EGF because G is not the vertex, and the vertex always needs to go in the middle. Okay. Another thing that you can call this angle is GFE because F would still be in the middle. Okay, so either way. So supplementary angles are our first type of angle. And now let's look at another type of angle. It's very similar. It's complementary angles. Complementary angles are two angles with a sum of 90 degrees. Okay, so these ones add up to 90 degrees. Real quick, while you guys are writing that down, how many of you have a yellow 5-minute early pass today for 12Cs? Okay. Okay. Make sure that I remind me, and then I'll just need to see your pass before you. Actually, I think I have to collect it. I'll collect your pass on the way out the door. Okay, so make sure you have your pass handy when it's 5 minutes till the end of class. All right. So let's take a look at what complementary angles look like. Complementary angles are the nicest angles. Nobody got my joke. At least one person in first period laughed. Okay. I'm going to give this angle a name here. Okay. So I'm sure you've seen it before, but this little box means that that's a right angle, or that it has 90 degrees. If the measure of that angle is 90 degrees. And since complementary angles add up to 90 degrees, if you see this, you know that this angle and this angle are complements of each other. Okay, they add up to 90. So what we can say is that the measure of angle ABC plus the measure of angle CBD is equal to 90 degrees. And just like supplementary, they don't have to be touching to be considered complementary angles. As long as they add up to 90, they're complementary. So sometimes you'll have angles that don't touch each other like this. And my picture is definitely not drawn to scale. I imagine if we measured those two angles, they probably wouldn't actually add up to 90, but we're gonna assume that they are. So we can say, and I'm gonna show you one more way of writing an angle too. If you have an angle that is all by itself, there's no other angles coming off of the same vertex, we can just say measure of angle F. But I couldn't have done that here, because then you would be saying that this is angle B and this is angle B, and you have to be able to distinguish between the two. So I can only do that when I have an angle kind of floating out in the middle of nowhere with no other angles around it. So this could be called angle F, so the measure of angle F plus the measure of angle J is going to be 90 degrees. And I put an example on the board here too. If I have this angle, we have three ways of naming it. We can either do EFG, remember that F has to be in the middle, or we can go the other way, GFE. And since there are no other angles coming off of your vertex F, We can just call it angle F if we wanted to. Okay, so that's 3 ways to name it. Okay, so we have supplementary, complementary, and now let's talk about adjacent angles. So let me pull my thing up real quick. Adjacent angles are 2 angles that share a common vertex and side. So let me show you a picture of what that looks like. Okay, so these would be considered adjacent because they're touching each other. They're right next to each other. And the most important thing is that they have a common side. So here's the common side. And they have a common vertex. So these would be considered adjacent angles, angles that are right next to each other. All right, so that's adjacent angles. Now let's talk about vertical angles. Gosh, I feel like I'm putting you guys to sleep. I see everybody yawning. It will be more exciting after today, I promise. We just have to get the background knowledge, and then we'll get to solve problems with these. Okay, vertical angles are angles formed, so they are 2 non-adjacent angles that are formed by 2 intersecting lines. Okay, and I'm going to add a little bit to that, so leave a little bit of space, because we're going to add to it in just a second. And we're going to draw a picture of vertical angles. We're going to call this A, B, C, D, E. Okay, I'm going to show you what happens with vertical angles on patty paper. If you've never seen this stuff is awesome. It's like tracing paper, and you're going to use it a lot next year in IM1, okay, for some various reasons, various things you'll be doing. Okay, so what I'm going to do is I'm going to explain vertical angles to you by using the patty paper. So you can just watch this part. I'm going to transfer my intersecting lines onto my patty paper. Oh, kind of went off a little bit on there, but okay. So the cool thing about vertical angles is, let's take a look. These would be considered vertical angles right here and here because they're across from each other. Now if I fold my patty paper right on the vertex, you can see that those two angles line up exactly. You see that? Right on top of each other, okay? So these are the same measure. So we can say that this angle and this angle are the same. I can do the same thing the other way too. If I fold the paper the other way, you can see that this is another set of vertical angles. Another set of vertical angles, okay? But let's just focus on the ones that I wrote here, okay? So we can say angle A, B, D, so this angle right here is congruent to angle CBE. Now, you might not know, have you guys seen this symbol before? Maybe, kind of, okay? It basically means that they have the same measure, okay? So we're saying that this angle and this angle have the same measure. So I'm gonna add on to the definition. We can say they are congruent, meaning that they have the same measure. They're congruent. Okay. I have one more thing to show you before we're gonna do a group jam after this. So I'm gonna turn the page on my vocabulary sheet. So let me zoom out so you can see. Oh, this doesn't zoom out very far because it's a video. But like, you open it like a book. So I'm gonna open it like a book and I'm gonna start right here. So I'm gonna turn it inside out basically. And there's the front, and I'm gonna put my next vocabulary word right there. It really doesn't matter because it's your vocabulary sheet. You guys get to use this on the test. So you're the one, I mean, it's wherever you want to put your vocabulary on this foldable is fine by me. So make sure you're taking good notes because this is gonna be your buddy on the test. I just wanna make sure we have a solid definition for congruent before we start our IXL. Okay, so what congruent means is it means to have the same size, shape, and measure. Okay. Now, a lot of things can be congruent. Line segments can be congruent. Angles can be congruent. Shapes can be congruent. Any shape that has the same size and measure and shape, it would be considered congruent. So I'm gonna just, I'm not gonna teach, you guys aren't gonna be required to learn how to do constructions in this class just because we don't have enough time. But it's one of my favorite things to do. When I was in college, my favorite math class that I ever took was called the History of Mathematics. And so I got to learn how ancient civilizations did math. And one of the things I learned is how to use a compass and a straight edge to make figures and to make congruent figures. And I learned a lot of cool stuff. Like I could make a regular pentagon with just a straight edge and a compass. It's really neat what you can do. So I'm gonna keep it super basic today though. I'm just gonna make a congruent line segment first of all. So I'm gonna put a line segment here. We're gonna call it A, B. Now you don't need to do this part, but I'm gonna show you how I would use my compass to construct a congruent line segment. So I'm gonna make my second line longer than my AB line segment. I'm gonna put a point here. So this is what I do. I'm gonna use my compass kind of as like a measuring device. I'm gonna come out and I'm gonna measure AB first. Okay, that looks pretty good. Now I'm gonna take the point of my compass down to my second line. It's actually a ray. And then I'm going to just put a little mark there to show how long the line segment should be. And we're going to give this a name. We're going to call it CD. Okay, so I constructed it, so I know it's super congruent. So we can say line segment AB is congruent to line segment CD. I know they have the same measure because I constructed it using my compass, okay? Now, this right here is considered a congruent symbol. And this would be considered a congruent statement. Congruence statement. Okay. Now, I'm going to show you one more thing. Obviously, I'm not asking you to do it, but I'm going to show you congruent angles, and I'm going to construct a congruent angle so you can see what that looks like. We're going to call this angle FGH. Okay, and so I'm going to construct an angle congruent to that. So I start with a line. I'm going to put a point on my line. Now what I do is I open my compass just to any opening width. I make it so that I can put an arc on here that goes across both sides. Okay, so there's an arc that goes across both sides. Then I'm going to come over to my line, put the point of my compass at the vertex, and recreate the same arc that I just did on the other angle. Then I'm going to come over to my original angle and I'm going to measure the arc. Okay, that looks pretty good. So I'm going to come over to my new angle, put the point of my compass there, and mark the measurement that I just took off of the other angle. And where those two little arcs cross is where my line is going to go through. So you're not constructing these, but you can just write down two angles and call them congruent. We're going to call this angle JKL, and we can say that angle, you can either call it FGH or just G, is congruent to angle K. So there's a little bit of fun for you. I have to throw some constructions in since I'm not teaching you guys how to do it this year. All right. Yes, Kello. Because that's how you do line segments. So to show that it's a line segment, you put the line above AB to show this is line segment AB. And then here, these are angles. So we use the angle symbol to show that this is angle G, and that's angle K. So there's just different symbols for depending on what it is that you're writing. So good question. Okay, log into iExcel because we're going to do a group jam together. You guys might want to leave your vocabulary sheet out so you can reference it while you're doing iExcel. Yeah. What's your question, Maggie?